Hello, grade 8 students. Today I will be discussing linear function. So again, what is a linear function? A linear function is a function whose graph is a straight line, and it can be written in the form y is equal to mx plus b, where again your x and y use as the independent variable and the dependent variables. And the slope should not be equal to 0. So what are the conditions that will satisfy whether a given equation is a function or is a linear function? Again, number one, the graph is a straight line. Number two, it can be written in the form y is equal to mx plus b. Number three, again, the degree definitely should be 1, or it means the highest exponent is 1. And last condition is the slope should not be equal to 0. So in short, every linear equation whose slope is 0 will not be considered as a linear function. For example, y is equal to, sorry, for example, x is equal to 5, definitely it will not be a linear function because the slope is 0. Okay, so let us identify whether the following function is a linear or not. So in short, for the, numbers 1 to 5, all of the given expression is a function, but we have to identify whether it is a linear function or not. Okay, number 1, y is equal to negative 3x plus 1. So again, the degree should be 1, and here the degree is 1 because the exponent of x is 1. Number 2, as we are getting the slope is negative 3, so therefore, the slope is not equal to 0, so check, it is a linear function. So the answer is yes. Okay, for number 2, y is equal to 2 over x minus 7. This one is not a linear function because as you can see, we have a variable under the on the denominator, or as we rewrite this expression, it is the same as 2x raised to negative 1, where our degree or the exponent of x is negative 1, and definitely that will not satisfy the condition under linear function. So this one is not a linear function. We consider this one as a function, but it is a rational function, which will be further discussed on your senior high school. Okay, next, number 2, y is equal to 5x. Okay, the degree is 1, check. Number 2, the slope is 5. So yes, it is a linear function. Next, number 4, y is equal to 3x squared minus 5. So let us check the degree. The highest exponent of the variable is 2. So therefore, this function is not a linear function, but it is a function, and we consider this one as a quadratic function, which will be further discussed on your grade 9. Next, number 5, y is equal to x raised to 1 half plus 5. Definitely, the degree is not 1 because the exponent is a fractional exponent, and we can also rewrite this expression as y is equal to the square root of x plus 5, which is not a linear function. So this function is what we call a radical function, which will be further again discussed on your senior high school. So I'll repeat, to tell whether the given expression is a linear function, I'll repeat. Number 1, the graph should be a straight line. Number 2, the slope should not be equal to 0. And please do remember the degree is 1, or the highest exponent is 1. Okay, next, let's go now to the domain and range of the linear function. So again, when we say domain, that will be the set of all the x coordinates. And when we say range, that is the set of all the y coordinates. And as we graph the linear function y is equal to 5x plus 3, it is a straight line, and definitely it will extend on both directions. Okay, so I'll repeat, it will extend on both directions. So therefore, the domain and the range for every linear function will always be the set of all real numbers, because there's no restriction when it comes to the values of y. So we can have any infinitely many solution for this one. So y is equal to 5x plus 3y. So again, for every linear function, the domain and range will always be the set of real numbers. Next one is function notation. It means how are we writing a function. So in writing a function, y will be replaced by f of x. So as you can see, we aside from using f of x, we also use g of x and also h of x. Okay? So it signifies that every time that you will see this notation f of x, it signifies that the given equation is a function. And in that function, x is the independent variable. It can stand alone. And f of x is a dependent variable. It will depend on the value of x. That's why our f of x or y will be the independent variable. So here's a question to think. Does all equation a function? Why or why not? So for my example a while ago, all of them are equations and definitely all of them are functions. But do we have an example of equation which is not a function? Is it a yes or a no? The answer, let's see. Okay, so let's have the equation y is equal to 4x plus 3 and that is a function. Definitely it's a linear function. Number 2, y is equal to x squared minus 4. It is also a function which is a quadratic function. But for number 3 equation, y squared is equal to x plus 2 is not a function. Why? If you are going to graph this one, which is the easiest thing to do, okay, we will graph this one as a parabola which opens to the right. And again, to check the graph, whether it is a function or not, we have to use the vertical line test. So we need to draw a vertical line on our graph, and if intersects the graph in more than one point, therefore it is not a function. And as we draw a vertical line, it intersects our graph in 2 points, so therefore it is not a function. But if you're going to use table of values, definitely we will have a repeated abscissa, so therefore it is not a function. Okay, so I'll repeat, not all equation can be considered as a function. Definitely there are restrictions. And this is one of the example. Okay, now, let us now, what are we going to do is to represent the given problem in a linear function. So problem number 1, an apple cost 18 pesos. Express the total cost of the apples as a function of the number of apples x bought. How much will it cost to buy 15 apples? Definitely, you can answer this one without any equation at all. Why? Because what are we going to do is just to simply multiply the cost of the apple to the number of items or products that we need to buy. So that will be 15 times 18. But again, our goal here is to represent this one in a linear function. So your f of x here will be the cost of the apples and x will be the number of apples. So the function is f of x is equal to 18x, where 18 is the cost of the apple and definitely it's constant because on the given problem there is already a price. And then x, it will depend on how many apples are you going to buy. That's why the given expression or the given function would be f of x is equal to 18x. And then to answer the question, we just need to substitute x and make it 15. So that will be f of x is equal to 18 times 15, which will give us 270. So therefore, it will cost 270 pesos to buy 15 apples. Next, problem number 2. A cell phone plan costs 1,800 pesos per month plus 500 pesos for every gigabyte of data above the monthly allotted data. Express the monthly cost of a cell phone plan as a function of the excess gigabytes x of data used. Determine the monthly cost if there is an excess of 2 gigabytes used in each month. So again, here, our f of x will be the monthly cost of the cell phone data. And the x will be, of course, the excess data used. So here, as in the given problem, the constant will be the cell phone plan, which is 1,800. So it will only differ on the number of data or the excess gigabytes of data that you're going to use per month. So therefore, the linear function will be 500x. Again, 500 will be for the number, 500 will be the the cost of 1 gigabyte of data per month. Okay? Plus, again, 1,800 is the constant, which is automatic, will be on your monthly cost of the cell phone plan. So that this will be our linear function. And to get the answer, for the monthly cost, if there will be excess of 2 gigabytes used in each month, so we just need to change x and make it 2. So 500 times 2 plus 1,800 will give us 2,800. So therefore, the monthly cost of cell phone plan, if there is an excess of 2 gigabytes use, is 2,800. Okay, that's it. Again, when we say linear function, the graph is a straight line, okay, and your slope should not be equal to 0, and then the degree is 1. So that's it. Thank you so much for watching grade 8. See you again next time.